Hello, this is Susan Poss at Spartanburg Community College. I am going to be working today in section 10.6, graphing linear inequalities in two variables. And there are some important vocabulary words here that I wanted to be sure to talk to you about. The first one is half plane. So what we're going to be doing is looking at a grid. We're going to be graphing these inequalities. So we're going to be looking at a grid, and we're going to be putting in a straight line. And that straight line then is going to split this grid into what are called two half planes. So let's imagine that this is our grid. There's the x and the y axes. And then let's say that the line that we graph looks something like this. So you see how that line that I just graphed there takes the grid, and there's a region up here above it, all of these points up in this area. That's one half plane. And the other half plane is all the points over here on this side of the line. So the half plane is that whole region, that whole section that's on one side of the line, or the other side of the line. Okay, so that's the first definition you need to know, is a half plane. Maybe I could sketch that in with some different colors. So just to show you, here's one half plane, all the points up above that line, and here is another half plane, all the points down here below that line. So that's all that's saying, is the line itself is going to separate the grid into two halves, two half planes. And the line itself, you can see my next vocabulary word here, is called a boundary line. So the boundary line is that line that I drew over there. Sorry. The line that I drew over there that separates the grid into the two half planes. So we've got a half plane, two half planes on the grid. We've got a boundary line. And then we're going to have one of two things occurring when we graph these. If the inequality is a less than or equal to, or a greater than or equal to, when we draw the graph of the line, we will draw it as a solid line, like I did in the previous one. So those are inequalities that include the boundary line. So we're going to have a half plane and we're going to have a boundary line included if we have less than or equal to, greater than or equal to. So that's what your eye is going to check for as you're drawing the line. And the other thing that can occur here is that when you graph the boundary line, you're going to check and it will say less than or it will say greater than. There will be no or equal to. So it will be a strict inequality, strictly less than or strictly greater than. And when you draw that line, you're going to draw it using dashes to indicate that that boundary line is not a part of the solution. The half plane on either side of that boundary line will be in the solution, but the line itself will not be. So you're going to have a difference of sometimes when you shade in the half plane, let's just say, for example, on that one, that's the half plane that we're interested in. And that one shows you that it also includes, the solution set also includes the boundary line. However, on this one, if we shade in that half plane again, because the boundary line is dotted, that indicates that those dots, those points on that line are not included. And again, the key is, do I have an or equal to mark in the symbol, or do I not have an or equal to mark? All right, so that gets our vocabulary out of the way. Here is an example just to show you. In the first graph, you can see, let me rewrite it and get it out of the picture here. It's 2x minus 3y, and this one is strict, is less than 10. And you'll notice here that this boundary line is dotted. And so that says the solution set includes all the things that are in the shaded region of the half plane, but it does not include the things that are actually on the boundary line. And of course, the difference over here is the same inequality, same graph, except, and let me put this in red right here, you have the or equals to, and of course that means that we do include the points that are on the boundary line, and we include the points that are in the half plane. So when you get these solutions, you're getting infinitely many points. And so it's going to be all the points on in one of the half planes, and the only decision you're going to have to make is, number one, which half plane do I shade here? Where is my solution group? And the other one is to take a look at the line and make sure you draw it appropriately, either dotted or solid. So I lifted out of your textbook a couple of steps here. They gave you a couple of methods. I'm just going to use method number one. So the first thing we're going to do is graph the boundary line. And as we graph it, we need to make sure that we know whether we make it dashed or solid. So we've already talked about that. And then we have to decide where to shade, which half plane do I include in my solution set. So what I'm going to do is just test a point to see if it works in the inequality, and if that point works, then I'm going to assume that all the other points on that half plane are going to work. Okay, so and it also suggests, and you're going to see me doing this, that if you can determine that the origin is clearly not on the line, then that's a really good test point because it makes your arithmetic quite easy. All right, so here's the first one I want to work for you. So the inequality says 2x plus y is less than or equal to 6. And I can already see that when I draw this boundary line, I'm going to make it solid because I am including the points on the boundary line. All right, so usually what students find the easiest thing to do is to turn this into an equation for just a minute. And I like to, in this case, it's pretty easy to solve explicitly for y. This is the equation of the boundary line. So I'm going to go over here and graph it. So I know that the y-intercept is at 6, and I know that the slope is -2, and I'm going to put that over 1. So I'm going to begin here by plotting 0, 6, and then I'm going to drop down 2 and go to the right 1, down to the right 1, down to the right 1, and I'm going to try to sketch in. And as I sketch this line, I'm going to make it solid. Remember, we've already determined that by looking at that or equal to. So let me see if I can get that boundary. That's pretty good. It's not great. It's hard to draw these electronically and get them right. Okay, so I've got the boundary line. Yay. And I know I should have it solid, and I do have it solid, so that's good. The last thing I need to determine is where to shade. So am I going to shade all the points to the right of that boundary line, the upper right? Or am I going to shade all the points over here to the left of that boundary line? And remember, we said if you can determine that the origin is clearly not on the boundary line, and it is clearly not on the boundary line here, then you want to use that as your test point. So this is, again, method 1. So you go back to the inequality. So you leave the equation. The only reason you put it into an equation is to get the boundary. Go back to the inequality. Plug in a 0 for x, a 0 for y, do the arithmetic, and see if this is true. Is it true that 0 is less than or equal to 6? It is less than 6. So that means that 0, 0, that origin, is one point in my solution set. So what that tells me is that since 0, 0 satisfied the inequality, I'm going to want to shade on that side, because that point satisfied the inequality, and I know then that every point on that side will satisfy. All right, so let's look at one, and I couldn't get things situated the way I wanted to. Let me write it on down here. All right, so this one is y, was it less than? It was greater than 2x. Okay, so I can already tell you that my line needs to be dashed or dotted, because I don't have an or equal to included here in this inequality symbol. So I'm going to convert this into an equation real quick. And I'm going to go ahead and put it into slope-intercept form. I can stick a 0 plus 0 out there, and I can now tell you that the y-intercept is 0, 0, and the slope is 2 over 1. So let me go over here and plot 0, 0, and then I'm going to count up to over 1, up to over 1, and so forth until I get up to and over 1, a series of points. Now remember, this line does not need to be solid. This line needs to be dashed. So let me see if I can make that look halfway decent. So we've got our boundary, but we're not going to include those points in the solution set. All right, so the next thing I need to do is a test point. Well, this time the point 0, 0 is clearly on the boundary line, so I cannot use that as a test point. So you can just choose something that looks kind of easy for you. I think I'll choose the point 3, 1. And you've got millions of choices over there. I'm going to choose the test point 3, 1. And I'm going to test it. I'm going back to the inequality. Y greater than 2x. I'm going to put in the 1 for y, and the 3 for x is 1 greater than 6. This is not true. 1 is not greater than 6. So that means that this point 3, 1 is not in the solution. So instead of shading where I selected the point, this time I'm going to go and shade the other half plane, because the point that I selected was on the other side. It did not check out, did not satisfy the inequality. So I go to the other side, process of elimination. All right, then there were two others that were just kind of special cases. I can do these pretty quickly. The first one is y greater than 1, and again, I already know that my line is going to be dashed. If I go to the equation form in order to get the boundary line, I hope that you know already that this is going to be a horizontal line. And again, I'm just going to come in here where y is equal to 1 and put in a dashed or dotted boundary line. And then I will pick a test point. I could pick the origin again. Which is right here. So I'm testing 0, 0. If this works, I'll shade down below. If it doesn't work, I'll shade up above. So you go back to your inequality. Y greater than 1. And the y value that I have here in this point is 0. So is 0 greater than 1? It is not. That is not true. So this point 0, 0 is not in the solution. not in the half plane that I'm looking for. So I will simply go up above here and shade the other half plane. So a dashed line and up above. Some of that you can do with common sense. You don't actually have to have a test point. And the last one I wanted to do for you, again, is kind of a special case. It's x, I can't quite read that. It was, when I blew it up, it was fuzzy. Less than or equal to 0. I can already tell you that this line is going to be solid because of that. Or equal to. I'm going to go to the equation to get the boundary line. X equals 0. I hope you already know that x equals a number gives you a vertical line. So I'm going to draw in, I think I'll use a different brighter color so it shows up a little bit better. Here's the line x equals 0, and I'm making it a solid line. And then I'm going to choose a test point. It will not be 0, 0 this time because you can see 0 is actually on the line. So maybe I'll choose 3, 3. And again, you can choose whatever you want. Go back to your inequality, put in the x coordinate, and ask yourself, is that true? Is 3 less than or equal to 0? That is not true. So that means that this point 3, 3 is not in the solution, not in the half plane that I'm looking for. So since that is not in the solution, I'm going over here to the other side and shading that. Okay, so I'm going to stop right there. I hope that helps you with section 10.6.